My name is Michiel Lyons, and the purpose of this presentation is to demonstrate to you how to carry out assignment problem 1, specifically question 1, how to solve that in Matlab. Now, the first step is let's define the equations and see what happens. The question is, predict the life of the panel in loading blocks using linear elastic fracture mechanics. Hint, assume that the crack growth per block is small in comparison to the overall crack length and that failure is due to fracture and not plastic collapse. Right. The first thing that we need to find out is what is the critical crack size. So let's make a note here, critical crack size. As you know, the critical crack size depends on whether the failure is plastic collapse or fracture. In this case, if I read through the question, they don't say anything about yield strength. So I'm going to make the assumption that the critical crack size is dependent on, will be driven by fracture. Now, so it is assumed in this problem that the critical crack size is when fracture occurs, that is alt nu EI, that is when the stress, the maximum stress intensity, mode 1 stress intensity, which is equal to the maximum stress, so let's say sigma max in this case, sigma max times the beta times square root by A is equal to, in this case, 50 MPa square root meter. We know in this case sigma max, or let's say K1C. Now if we look at the problem, right, we can clearly say that from the problem, we can say that in this problem we have M is equal, sigma max is equal to 280. So we have 280, right? Or let's write an equation for the critical crack size. So in this case, we can say A is equal to K1C divided by beta, right, squared times 1 over pi. 1 over pi. Right. So that's what we have for this problem. Good. Now, when I have A now, in this case, I'm sorry, and then there's sigma max. Sorry, there's a sigma max. That must come into there. And that's the equation that will give us A from the equation above. Now, the question is, what is beta? They say an infinite center crack panel is subject to the uniform cross-section. I'm going to open the notes where we look at the beta values for these cracks. This is the note that we have for a center crack specimen, and here we can see that beta is equal to 1 plus 0.256 A over W minus 1. You can see the rest of the terms. Now, in the question it was said, an infinite center crack panel. That means W is infinitely large. So when W is infinitely large, beta is basically equal to 1. So I'm going to use that here. So beta is basically equal to 1. And here we can now write that this is equal to 1 over pi times, in that bracket we have 50 divided by, what is the maximum stress? The maximum stress, tensile stress, is 280 MPa, right? And I must multiply that by beta, which is 1, and this must be squared, and I'm going to calculate that in Matlab. and I found that the answer is 0.01 meter and or equal to 10 millimeter. So that is the critical crack size that we have for this problem. I'm going to stop the video here, and in the next video I'm going to show you how to calculate the crack growth per block.